All right, we're going to talk about the sum of interior angles of polygons. And first, refresher on the word polygon. A polygon is any two-dimensional or flat shape that has only straight sides. So there's nothing curved, all straight sides. And a lot of the shapes we deal with are polygons. You see several examples right here. And the most basic polygon is a triangle. It has three sides. You can't have fewer than three sides and make a polygon. And we know with a triangle, with our three-sided figure, that the sum of the interior angles is 180 degrees. That's something we deal with quite a bit. You may also know with a quadrilateral is four-sided. That would include all your rectangles and your rhombuses and other types of parallelograms and things like that. Any four-sided figure, the sum of the interior angles will always be 360 degrees. With a pentagon, which is five sides, they always add up to 540 degrees. So what's happening here is every time you add a side to a polygon, you increase the sum of the angles by 180. These angle numbers just keep going up by 180 degrees every time. So if you go to a hexagon, six sides, you add 180 again, and you'll find that the angles add up to 720 degrees. A heptagon, which is seven sides, which we don't see that often, but it's still a thing. Those will add up to 900 degrees on the interior angles. And an octagon, your trusty old stop sign there with eight sides, the angles would add up to 1,080 degrees. Now, we can make a table like this and just keep adding 180, but if we have to work with like a polygon with 20 or 30 or 50 sides, that's going to take quite a while. So we also have this little formula that you'll see at the bottom of the screen. It's S minus 2 times 180. And what S stands for is the number of sides in the polygon. So, like for a triangle that has three sides, if we plug that into the formula, plug 3 in for S, we'll have 3 minus 2 times 180. 3 minus 2 is 1. 1 times 180 is 180. And that's what we know a triangle's angles add up to. Quadrilateral has four sides. We're going to do 4 minus 2 times 180. And 4 minus 2 is 2. 2 times 180 is 360. So it works again. And you can kind of see what's going to happen as you add in bigger and bigger numbers. Now, really quick before we go on, if you're watching this video after you've done our Monday Google Meet, then you have already seen a little bit about why this happens, why this works this way. If you're watching this before our Monday Google Meet and you're a little confused about like, why do we add 180 every time? Why does this work? That is what we're going over on the Google Meet. So you'll get an understanding of like where this comes from and why it works the way it does. The one thing you really want to make sure you remember from this is this little formula here. The number of sides minus 2 times 180 will tell you the total of all the interior angles when you add them together. So let's do a couple types of examples. One type of examples you will get, or one type of problem you will get with the sum of interior angles is you'll get a polygon with varying angle measurements. And you'll notice here you have some of these. You just don't know. You just have an X. And you'll have to use what you know about the sum of the interior angles to solve for X. So the way you work these out is first you have to know how many sides are on the shape. And you just count these up. This is 1, 2, 3, 4, 5, 6, 7. So we have a 7-sided shape. We have a heptagon. The next thing we need to do is figure out what is the total of all 7 of those angles. So we're going to use our little formula. We're going to use S minus 2 times 180. And we're going to plug in the number of sides, which is 7. So we have 7 minus 2 times 180. 7 minus 2 is 5. 5 times 180 is 900 degrees. So these angles add up to 900 degrees. So that's the first thing we need to know to be able to work this out. The second thing we need to do is, like we've done a lot with triangles, is add up all of our angles. So I'm going to start with this x and just add them all together. And it's going to be kind of tight because there's a lot of them. But we got x plus 102 plus 165 plus 123 plus x plus 11 plus 128 plus 161. And I'm back to where I started. So that should be 7 angles, 1, 2, 3, 4, 5, 6, 7. And those add up to 900 degrees. And so what I want to do now is I want to combine my like terms. Well, the x's are easy. There's only 2 of them, so we'll have 2x. The other numbers, that's going to take a little bit of work. I'm going to just work this out to the side. We have the 102, the 165, the 123, the 11, the 128, and the 161. So when I did that, I got 690. So I have 2x plus 690 when I combine all my like terms, and that is equal to 900 degrees. So now I just have a little 2-step equation I can solve. This is very similar to what we've done for triangles now. So I will subtract the 690, and then I will have to divide by 2. So I should get 2x equals 210. When I divide by 2, I will get x equals 105 degrees. So that's how you do it. The first thing you have to do is figure out the total of all of the angles, and then you will add up all the angles you know, set it equal to that total, combine your like terms, and then work it out from there. So let me clean up some space over here to do the second example. The second example, if you look at this shape here, we have a pentagon. So 5 sides. I'm going to do this in a different color so it'll stand out a little bit. So 5 sides on here. So we're going to take 5 minus 2 times 180. 5 minus 2 is 3. And 3 times 180 is 540 degrees. 540 degrees is what these will add up to. So I got 5 expressions here. Let's start adding them together. I have 5x plus 2 plus... I'm starting here at point A, and I'm going to go around clockwise. 3x plus 5 plus 8x plus 8 plus 4x plus 15 plus 5x plus 10 equals 540. So now I'm going to combine my like terms. I'm going to combine my x's. I've got 5x, 3x, 8x, 4x, and 5x. That should give me a total of 25x when I add all those together. Then I've got a 2, a 5, an 8, a 15, and a 10. That gives me 40 when I add those together. So when I combine my like terms, I get 25x plus 40 is equal to 540. And then I'm just going to solve my equation as usual. Get 25x equals 500. And when I divide by 25, I will get x equals 20. And one quick way you can check this is you can plug x back in and just see if you get reasonable angle measurements. So if I plug 20 in for x on angle A, I have 5 times 20 plus 2. That would give me a 102 degree angle. That seems pretty reasonable for angle A. It looks like it's an obtuse angle that's not that much bigger than a right angle. For angle B, I plug in the 20. 3 times 20 plus 5 gets me 65. That seems to work. And if you really wanted to check it, you could plug in x for all 5 angles, add them up, and make sure you do indeed get 540 degrees. So that's one type of problem you'll get where you have to find the total of all the angles, add the angles together, and then solve for x. The other type of problem you'll see involves regular polygons. So quick refresher on the word regular. Regular means that all the sides and angles are congruent. So example 1 on this slide, it says find the measure of one interior angle of a regular octagon. So this is an octagon here. It has 8 sides. The first thing we want to do is find the sum of the angles of an octagon. So what I want to do is plug into our little formula. I have 8 sides, so I'm going to have 8 minus 2 times 180. That's going to be 6 times 180, which gives me 1,080. So my 8 angles of that octagon add up to 1,080 degrees. Now here I know because it's regular that all 8 angles are congruent. They're all exactly the same. So whenever you're dealing with a regular polygon, what you would do is take that total, so in this case 1,080, and you would, well, first you have to write it correctly, so apologies for that. All right. You take the 1,080, the total, and you divide it by the number of angles, since they are all the same. And when you work that out, you will get 135 degrees. So each of these angles in this octagon is going to be 135 degrees, and you can keep going around. Second example here, it doesn't have a picture, and if you read this, it says, find the measure of one interior angle of a regular 17gon. Well, that sounds funny. That's not a shape you usually hear about. And what happens here is after you get to 10 sides, you have names for all your polygons going up to 10 sides. You have your triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. And then after that, you kind of just start using numbers. Now, there's some of them like 12-sided figures, 20-sided figures. Those do have special names. But a lot of times, you'll just use a number and then a hyphen and then gon. So 17gon just means that it has 17 sides. If you saw a 42gon, that would be a shape with 42 sides. So we're going to plug 17, that's our number of sides, into our little formula here. And we have 17 minus 2 times 180. That's going to be 15 times 180. And when you work that out, you should get 2,700. So if you have a 17-sided figure, its angles will add up to 2,700 degrees. Now what we want to do is figure out what is one of those angles, because this again is regular. All the angles are exactly the same. So what we're going to do is take this 2,700 and we're going to divide it by the number of angles, which is 17. And I did work this out earlier, so I won't bore you with all the little steps here. What you get is you get 158.82, and you could keep going if you want. It gives you a pretty nasty decimal. But the problem here says to round to the nearest tenth. So that's one number after the decimal. So I'm going to round that off to 158.8 degrees. So if you have a 17-sided figure and it's regular, so all 17 angles are the same, each angle would be approximately 158.8 degrees. So that is the sum of the interior angles of polygons, and that's some of the problems you will be doing.